Hello, welcome. My name is Christian Mostert. I'm the Chief Operating Officer of Walden Associates. We're an environmental engineering consulting firm. And today we're going to be talking about how to organize and analyze your data with an environmental database management system. This presentation is really targeted at two groups of people: those who are responsible for managing the vast amounts of data that accompany environmental projects, and those who are responsible for analyzing that data to make key project decisions. So you want to know what an EDMS is and what it can do for you. Over the next few minutes, we'll cover what it is, how it organizes your data, and how you can use it to analyze your data. So if you have any questions, please type them in, and at the end of the presentation, we'll answer them. So data managers really face five major pressures in their jobs, or five expectations, I should say. They need to save money, save time, encourage better collaboration, produce better results, produce faster results. Your job as a data manager, you're always in the hot seat. You have to prove yourself every day. You have to prove that your way is better than the way it was done before. This is not a small objective, especially when your typical data situation, your typical data storage situation looks like this. Historically, this is the data situation you've been facing. Boxes and boxes of paper records stored on-site, off-site, wherever you can mash it in. But luckily, the digital age has helped address this situation to some degree, with Excel, Access, and document management programs becoming available. But it took a few years for someone to step back and really take a look at the big picture. With everyone creating their own little data warehouses, it's impossible to quickly and efficiently collaborate with other team members. Instant analysis is impossible because the data required long lead times to massage it into usable formats for the analysis software. And just forget about saving money. You know, the team of people needed to maintain the infrastructure, it was constantly growing. But thankfully, several companies have developed wonderful and thoughtful off-the-shelf environmental database management systems. Thoughtful is kind of an odd term to apply to an EDMS, I admit, but consider the variables developers are up against. They have to consider the needs of the field geologist or engineer, the client, the goal of infinite possible projects, the needs of a regulatory agency, and the role of the central data manager. So how does an EDMS provide a thoughtful solution to all these people? Well, it starts with organization. An environmental database management system, or EDMS, it's essentially a centrally located electronic file storage unit with virtually unlimited capacity for expansion. It's a database. Unlike traditional physical filing storage systems, the electronic nature of an EDMS makes data immediately accessible by anyone who needs it, regardless of where they are located. With an EDMS, you can essentially merge data from lots of different sources. You can make it accessible to your users, and then you can allow them to interact with the data through the analysis software packages that they use most. The workflow here on this slide was provided by Ursoft. They've developed one such EDMS known as Equus. I really appreciate Ursoft making this available to me for this presentation. With an environmental database management system, storage is just the beginning. It also supports project management, data analysis, and evaluation of solutions of options. Here are some ways an EDMS can kind of help us stay organized. One, it functions as a storage and resource library that houses both historical and incoming data. Once historical data is entered, it's available to anyone, forever. And newly acquired field data can be automatically uploaded electronically, so it's available right away. How many times have you prepared Excel tables only to find that there is an error in the result, or the unit's changing a low detection into a monster detection? Now hopefully you cut that before the table is delivered to the project manager or regulatory agency, but sometimes it's not. An EDMS, it'll eliminate those simple transcription errors by keeping the data digital and the path to the database more direct. There's just less Excel involved and less human error being introduced into your data. Chances are you're juggling multiple projects and your colleagues are located at multiple, perhaps even far-flung sites. Different users need different information for different purposes. An EDMS allows you to use and share files simultaneously. Anyone can instantly retrieve existing reports or create new ones. Information is always right at your fingertips. An EDMS allows easy access to information and it eliminates hunting for data files. An environmental database management system streamlines work processes, helping you achieve more effective time management. You don't have to hunt down what you need. You won't inadvertently miss or overlook important data because it's out of place or in someone else's hands. An uncluttered working environment helps you think more clearly and focus on the most important activities so you can work more productively and you can get your work done faster. Whether you're working in a commercial or public agency environment, you're better able to serve potential clients or your own constituents if you're efficiently organized. You'll be fully prepared, poised for action, regardless of the impending scope of work. And EDMS even helps you keep your budget organized by reducing wasted time and making the best use of your limited resources. And you won't have to pay for hard copy filing supplies or constantly growing need for physical file cabinets and storage space. How many dollars are you wasting every year with your expanding paper-based filing system? So let's quickly return to our 5 goals as data managers. An EDMS can address these issues and help you meet your goals. If you're a data manager, you know that every day you have to outperform the day before. Project managers, clients, the companies you work for, they demand these 5 goals. And EDMS is a fantastic step towards meeting these goals and the needs of the entire project team. In a way, you'll get to be the job hero. Here's how. You have to save money. An EDMS is an affordable and cost-effective to maintain and manage. You have to save time. Import data in minutes, free up engineering and other professional staff to focus on more productive activities. Strengthen collaboration. Widely dispersed colleagues can easily retrieve, sort, and analyze information in formats they can readily use and understand. Produce better results. An EDMS can handle projects of any size or complexity, eliminate human error, offer extensive customization, and offers flexibility. You have to produce those results a lot faster too. You can produce lightning fast analytical results you can rely on to evaluate and compare potential solutions sooner and more effectively. Perhaps you're not a data manager. You see the value in having the data in one location and making it accessible, but to you, that's not really your job. It's not your responsibility. Your job, your obligation is to analyze the data, make decisions, determine follow-up work, and communicate progress to the client, the regulators, and to your superiors. So you're wondering, okay, that's great, Christian, but what can an EDMS do for me? Well, we've talked about how data can be automatically uploaded from field instruments and lab reports, how it stores in possibly large data sets, it provides easy access to data, and all that's great. But now you want to dig into the data. The power of an EDMS comes through its availability to quickly and efficiently run queries, reports, perform calculations. The data can be sliced and diced any way you can think of. The units will be consistent even if the original data was put into the database with different units. In other words, whether it's parts per million or parts per billion, it can be converted to parts per million or parts per billion based on the needs of your particular project or your particular report. The system can maintain environmental quality standards known as action levels and compare your results against those. For example, say you have a VOC list for water quality standards. An EDMS will allow you to compare your results against that list and highlight the results in your data that exceed those standards. Most importantly, however, is the ability of an EDMS to quickly export data in formats that is consumable by third-party visualization software, such as ESRI's GIS, Surfer contouring, EVS, three-dimensional images, Google Earth, just to name a few. Let's take a look at a couple. Now, the evolution of our visual senses created an incredibly powerful system for quickly taking in information through your eyes, picking up subtle patterns, and making instant decisions. This is a photo is worth 1,000 words. This is how ancient man kept himself from being eaten by that saber tooth. It's how you can quickly interpret a multi-dimensional display of environmental data. Consider the screenshot here. It's made from the integration of ArcGIS and Earthsoft's Aquis GIS extension. You can easily see that the approximate extent of the plume, the location of each sampling point represented by the pie charts, the approximate chemical composition of each sample in those pie charts, and the detailed analytical results that are shown in the yellow bubbles. Now, how long would it have taken you to get a sense of what you see here from just normal analytical tables. Here's another example of the integration between a data visualization tool like GIS and EDMS. The orange, yellow, green, and blue colors instantly provide us some idea of the extent and concentration of the plume. The pie charts represent the sampling locations that help determine the boundaries of that plume. The pie charts themselves show us the chemical makeup of the 3 analytes from each sample. A noted benefit of this integration is that the EQUIS extension is used from within the ArcGIS, and it's directly connected to the environmental database running in the background. What that means to you is that you can run and rerun lots of queries on your data without creating and importing new tables into the GIS, adding another layer, trying to make sure that the data all works with the GIS. It's just instantaneous access. Let's take a look at a project I've worked on where EDMS made a very significant difference. Here we used EQUIS EDMS to support a fuel oil terminal site investigation. In this case, we use the organization and analytical qualities of an EDMS to consolidate the data from many different consultants and provide historical and spatial trends for the preparation of a remedial investigative report for the New Jersey Department of Environmental Protection. The fuel oil terminal was opened in the 1930s and it had changed hands a few times. There are 2 major known spills associated with the site, one in 1978 and one in 1981. The New Jersey DEP came up with a remediation agreement in 1997 with the current owners of the terminal. Now, the goal of this project was to consolidate the data collected by 4 independent consultants from 685 locations in 1,810 samples over the years. The data was in paper reports, it was lab data, Excel tables, Access, PDFs, you name it, we had it. But our job was to consolidate that data into one database so that we could look at the historical trends and then provide GIS spatial analysis through the ArcGIS interface with EQUIS to support the site-wide investigation. After analyzing the data, Walden then created the final figures to support the findings and recommendations. Up until this point, the data was held closely by opposing sides, the current owners and the previous owners, consultants, so no one really had a good, clear idea of what was going on that site. When the New Jersey DEP released the previous owners from responsibility, when a property sale occurred, all of a sudden we were able to get all of that data, but it was in multiple formats. So we took it, we massaged it, imported it into an EDMS, and for the first time, all the data was together and we could get a comprehensive historical overview of what occurred on site. Then we filed the report to the New Jersey DEP. We proposed a plan for remediating the site. So the comprehensive investigation considered total petroleum hydrocarbons, base neutrals, a few VOCs, metals, and hexavalent chromium. Hexchrome was included because the first 11 feet of the soil was made up of chromate waste fill from a previous area's state initiative. So after the data was loaded into an EDMS database, we used ArcGIS to produce some maps of the various chemicals analyzed by depth and also against the state soil cleanup standards. This I had kind of mentioned previously when I said you could enter some action levels or some report guidelines into the program and compare your data against those standards. Since many of these sample locations overlapped, we assigned priority to the highest concentrations in an effort to make those results really stand out against a very detailed, complex background. So here you're looking at hexchromium from 0 to 2 feet compared to the 20 parts per million soil cleanup standard. Next to it, you can also see samples taken from 4 to 6 feet for hexchromium, where, again, we were using a 20 parts per million standard. We then also prepared maps for total petroleum hydrocarbons from 0 to 2 feet on down. We were using a 10,000 part per million as the soil cleanup standard in New Jersey. You'll notice there are a few samples taken from the water, and those were collected due to a fuel oil release into the water in 1978. So there's also another map right next to the right of the other one, right to the right of the 0 to 2 feet, and it's showing you the 2 to 4 feet results. So we use spatial analysis and the historical aspects of the data to really be able to determine the extent and depth of contamination, and from that we were able to make very sound recommendations in our report to the New Jersey DEP. Now here we have a couple of charts that were prepared in the EDMS system. This is from within the EDMS system and not done by a third-party application. The time to prepare and change these charts, say from all the monitoring wells to say 1 or 2, it's just mere mouse clicks. Every aspect of the data can be queried, requeried, charted, recharted, with such speed and efficiency that the project managers were astonished at how much more time they had to review the data and the trends compared to the time they were spending on reviewing data and making charts. They were finally doing what they were trained and educated to do, and not just entering data into Excel and loading it up into a program. So in essence, they had switched their time from clerical work to a much higher order of work requiring their analytical expertise. Now, using Equus's graphical capabilities, we were able to quickly see historical trends, accurately demonstrate the impact that our remediation efforts were having on a site. Now, this was new for us to be able to actually process graphs and investigative trends for the spill site so quickly. Like most, we relied on the charting capabilities of Excel up to this point, but that relies on data being in the right format, correctly entered, and now the process is so lightning fast using good data management practices that we can produce these things on the fly. So at this time, we'd like to take a few questions from those of you joining us today. So my assistant Tony is going to read a few of the questions that you've written in.
Okay, the first question that we have is from Mike. He wrote, "I appreciate the presentation, but I still don't get it. Could you explain to me what an EDMS is in layman's terms?"
Okay, all right, Mike. This is a very good question, very common question as well surrounding EDMS. So to answer your question, I'm gonna try a metaphor. What I want you to do is pretend that it's 1990 again. You're going to go on a business trip. You're going to go meet a bunch of clients. You're in the environmental field. You're going to go meet them. You're going to, and I want you to think about all the things that you need to pack to take with you, right? So what do you have in mind? You're going to take your airline ticket, your paper airline ticket, a couple books and magazines that you're going to read along the way, right? You got your organizer, your calendar, your Zagat's book to figure out where to take your clients to dinner, pens, papers, you got to have your long distance calling card to call back to the office because you may not have had a cell phone then. You also have to have all your project files, your Walkman with your CD on it to keep yourself entertained on the plane. Maybe you've got the latest Pearl Jam CD in there too, and you're gonna rock out. And then Nintendo Game Boy or something like that. Right now, let's come back to the present. If you have an Android or iPhone device, take that thing out and look at it. Now, what did I describe in 1990 do you not have on that phone? You have one simple thing that you're sliding in your pocket and it does all of that for you. That's an EDMS. That's what an EDMS does for environmental data, is it provides you one central database to kind of merge and utilize all of the other methods that we previously had for storing environmental data. Excel files, paper files, lab data, reports. All of that is now centrally located and accessible. It's more accessible. You can reach in your pocket, get your iPhone out, and figure out where to go to dinner, find a map to get there. And EDMS can kind of show you, hey, what happened in 1990, what happened today, and how the two things relate.
All right, great. Second question we have is from John. He asks, how difficult is it to get an EDMS up and running?
All right, I guess this is kind of like the learning curve question. So John, in EDMS, what I would say with an EDMS is that, you're already familiar with the data. You work with environmental data every way, so it's not introducing new information. It's just packaged a different way. It's got a much shallower learning curve to it than say a GIS does, because you're already familiar with the data and it's tables and charts and queries. So really, once you just get used to looking at the program and understanding how the program presents information to you, after that, you're off and running. And I found that the learning curve is pretty shallow.
Okay, great. The third question that we have is from Kim, and she says, could you elaborate a little further on where exactly we would see savings after implementing an EDMS?
Sure, Kim, that's a good question. So where you're going to see savings, that savings comes in the form of time. Time and effort spent trying to pull all of this data together. You know, like, let's go back to our 1990 example, and you need to produce a chart or a map. So you have to run down to the filing cabinet and find some old data, get the current data that was brought in from the lab and look at it. And you got to take it over to the drafters and have them create a map. And then you're like, oh, nope, that's not the map I wanted. They have to redo it, so you're waiting all this time. You know, the savings now with an EDMS is that you're just sitting there at your desk and you're doing all this on your own time, and you're doing it very, very quickly. A few mouse clicks and it's done. You know, is there a cost to it? Yes, there is a financial cost to it, but you know, the cost is far outweighed by the cost of kind of continuing to maintain the old methods. Like, you're investing up front to save for the future. So I appreciate everybody's time today joining us, and you know, if you have any questions or anything that you'd like to discuss with me, here's my contact information, the office phone number, and our website. So please feel free to reach out. All right, thank you very much.